And I come from a complete biology background, like no programming. So when I started my PhD a few years ago, that was when I started learning R, and I kind of hacked my way through it. I've taken some Canadian bioinformatics workshops to help along the way. But it goes to show that you can learn programming even though you come from a biology background. So today I'm just going to go over a quick overview of some very, very basic uses of R and kind of how to get settled in RStudio. And everyone should also have two stickies, which is green and pinkish. So if you're all steady, you can just put like the green sticky on the back of your laptop so I can see it, and that'll just be like everything's going smoothly. And if you have a problem, rather than flailing your arms up, we'll just see the red sticky and then somebody will come and help you out. So if you have any questions along the way, just throw up your hands and we'll be good to go. Okay, so just a little bit of an introduction to R. What I'm showing you right now on the screen is RStudio, but the very basics of it, that's actually like a GUI that runs on top of base R. So this is base R, and in a very basic sense, it's kind of like a glorified calculator because you can put in equations and it'll give you an output. So everything we're doing is a command and an output. So R runs on a console, and you can do some basic things. For example, the first thing that you probably want to learn about R is that this is a put arrow. Oh, wait, let me make this bigger. So this is a put arrow. So you're putting the sequence of 1 to 10 into the variable x so that when you call the variable x, those values are stored within it. And you can also run functions such as mean of x. It'll give you the mean of all the numbers stored in that variable. So you can run everything in the console, but when we're programming, we like to do it in little scripts so that we can keep it here, and it'll keep a history of everything, and they can also highlight chunks of text and run them all at once. And it helps with reproducibility, so rather than kind of remembering what you did, this will kind of give an overview of all the things that have been in your code. And just something else for beginners, if you scroll up and down with your arrows, you can get a history of the code that you have written previously. So sometimes if you're kind of in the pace of it, and then you get kind of caught up with coding in the console, and then you have to transfer everything to your script, this is a good way of accessing the history. So everything in R can be done in RStudio, which is, again, just a GUI that's put on top of it. But for me, it really helps organize my thoughts and keep all the panels organized, because there's a lot of things floating around here. So the same thing we have, let me just make this fit on my screen. We have the console over here, and then our script over here. This lists all, I have a lot of objects in my environment right now, but all the objects, for example, if I put the 1 to 10 into x, x would be listed here as a numerical vector. And here there's a few other windows. For example, if you make plots or if you need help, they will be shown up here. And just a few things for like customizability. RStudio is really awesome because you can change your pane layout, or also I like the darker layouts, but for now I'll keep it in white. Yeah. So first of all, how many people have the packages installed? Okay. Does anybody not have the packages installed? I'm sorry?
Just installing.
Oh, you're just installing? Okay. So we'll be working with an R Markdown file, which is a little bit different than a base script. And it's really good in keeping all your thoughts organized, and it will help move, kind of put your thoughts in line with the code and the output. So to start a new file, you can go File, New File, R Markdown. You can choose which of the outputs you want, but you can also like switch between them quite often. So we'll stay with an HTML output and intro R. Okay, so this is what it looks like now. So it starts off with a little bit of an introduction up here. And this is a little bit of knowledge about what the file is. Actually, maybe this is a little... You can run everything in a base script as well, if you just want to write the code. So when you're using R Markdown, everything, well, this is what denotes a code, these 3 little black slashes, and then this is the language, and this is kind of like a header tag of what's going to be inside of it. So this is where the actual code is going to sit. And anything out here is in Markdown annotation, which means like there's certain formats that are easily accessible with like the headers, such as like this denotes a header. So all of this is going to be commented out. It's not going to be run as code, but it's good for you to say, now I'm going to be importing this data set in, and this is the analysis I'm planning to run. So it'll help put your thoughts with your code. So the first thing we're going to do is, for example, when we're setting up our packages, install packages, if anybody hasn't done that yet, declare. So before you have your packages in, they need to be within these quotation marks because R doesn't know what the sequence of letters are. So once you have Dippler inside, once you have Dippler installed inside R, then R knows that Dippler is a package. So when you're calling it back, it no longer needs the quotation marks. Does that make sense? So the two packages that we're going to be using today are Dippler and Tidy, which are up over there. I can put it in here. You can also concatenate them. So C is for concatenate in R if you're stringing multiple things inside. Tidier, close, close, close. Oh, another really awesome thing about R is its autofill. So if you're using an base R, everything that you can do in RStudio can be done. But for example, there's a package that I use a lot called featmat. So for example, if you're trying to call the function and you forget what it is, it'll suggest things that are already installed in. So I'm like, yes, I want featmat, but I forgot what are the parameters in it. And it'll show me right here that first of all, you have to put in your matrix. The next thing is you can specify the color. So all the options, all the attributes of the function are listed here. So if I wanted to just put X as my matrix, then I could be like, what else can I change? And you just press tab and it'll give you all these options that you can actually add on to it. So it really helps when you forget what is in it. And you can also call up help. So if you put a question mark in front of something that you guys actually have installed is arrange. So this is a function in the Dippler package. So if you put question mark arrange, it'll show which packages have this command in there. So for this one, it comes from the Dippler package. And the same kind of thing, it will be explained here. So the first thing that it needs is the data. And then all of these other arguments that can be manipulated would be listed here, but it's quite a simple function. And also the help functions will be helpful because they have examples at the bottom if you're trying to use these functions for the first time. And I guess a little bit of the syntax for our functions is when you want to plot something, for example. Equals. So here, the function that I'm calling up is plot. And then you open these brackets to enter what data set you want to put in it. So this X is just a sequential data set. And then main is the main title. So now I'm going to be modifying some of the attributes. So I'm going to name it a boring plot. But you can see, oh no. We'll just put in 5. So it's a pretty boring plot. But you can see here, you can string along a lot of these different attributes. For example, if I wanted to modify something else, if I put a comma there and press tab, these are all the different things that I can there add on to the plot function. Does that make sense? Okay, so the next thing that we're going to be working with is when you have a data set and you want to import it in, you have to specify how R is going to communicate with your laptop. So if you do get WD, which is working directory, so this is the directory of the computer that you're working from, get working directory will show you where it's currently reading information from. But if you wanna specify R to read in a file from a specific folder, you can say set working directory, open brackets, and then again, because this is a string of letters that R doesn't naturally see, you're gonna need quotation marks in there, and it will follow, and you can either like tab in, and it'll give you things, directories that are listed from where you were before. So I know in my base folder, I have my documents, and then I can go to my UofT coders folder, or you can just copy it in from like, information. You can just copy the string over, and that's going to be the directory of your file as well. So you can redirect it into a folder if you'd like. And then now when you do get working directory, it has been rearranged to that one. So that is always the first step when you're trying to work with your own data. So some things is, if you wanted to read in a data set, you can do data set, whoops, read.csv, and then in here you would put in your CSV file. So I don't have one. We're just going to work with a data set that's already that comes with installed in R. But a CSV file is a comma-separated value. So this is a pretty bareback data table, and this is the format I prefer reading in files. So this is how you would be able to read in your data set. And also, if you wanted to, you could write .csv, and then you'd be like, if you wanted to read out the vector x, then you say numeric.csv if you wanted to read out a file at the end of your analysis. All right, so what we're going to do now is we'll work with string. So Swiss is a data set that comes installed in R. And the first step when you're trying to look at some data set, a good first move is head. So head will just show the first few steps. Oh, also, if you're new to RStudio and you're on a Mac, Command Enter will run just that line. And if you're working with our Markdown, you can do Command Shift Enter, and I believe that will run the whole R code chunk. So head will give the first 6 lines of the data set. And you can see here, these are the row names. And then along here, it shows that there is displaying columns 1 to 3 out of 6 columns. So you can kind of tab through and see the values over there. So other parameters that you can look at as well is names, Swiss. So names will show you the column names. This is actually the same as column names Swiss. On the flip side, if you wanted to, you could do row names Swiss, Swiss as well to get the row names going down on the side. An interesting distinction that we have is class and structure. So the structure of Swiss, bigger. So the structure of Swiss overall, it is a data frame, but each of the columns have their own vector type. So the data frame of Swiss is made up of this column fertility, which is a numerical vector, and agriculture, which is a numerical, examination, which is an integer. So if you did class Swiss, it gives you similar information, but stripped down if you only wanted the overview data type, the more wholesome view, like Swiss itself, the object is data frame, but you can extract out these numerical and integer vectors as well. So another question that comes out with data sets is when you're subsetting. So Swiss, for example, if this number sign will allow you to take out different columns. So RStudio will preset, it'll go in and look at the column names and display some options for you. So it shows that these ones are the column names. So if I just wanted to look at the column of fertility in the Swiss data set, the number sign is how you would denote that. You can also say, I want Swiss, just the first column, and it will pull out the same thing. And actually, if you do Swiss double column, it pulls out just the information in the vector. And this is different. This is different from just doing the single bracket because Swiss 1 class Swiss 1. Doing the single bracket will pull out just the first column as a data frame, whereas the second one will just pull up the numerical vector that makes up that column in the data frame. So this is a distinction you have to remember when you're subsetting data to be putting into other functions, because sometimes they will need numerical vectors, sometimes you can put it in as a data frame itself. Yeah. So also the format for subsetting, if you are looking for specific things within a data frame, is when you're putting these square brackets are really useful for subsetting, and you can put in 2 numbers. So here it's always rows and then columns. So this is denoting that I want rows 1 to 10 in the first column of Swiss. So that is how you can subset out specific data points. Everyone good so far? Okay, so that's more my overview of how to navigate in R. So next we're going to move on to a little bit of data wrangling and some packages that are really helpful that build upon base R, so diplower and tidy. So another thing that is common in these diplower and tidier packages is the use of a pipe. Sorry, I'm so disorganized here. So let me just insert a new R chunk. So I think it's this one. Yeah, so I was just figuring that out. Command Shift M is a shortcut to type this guy out. It's, oh, the code chunk? Does anyone, do you have it? I always do it from the top here. Yeah?
Command Option I on that.
Command Option I? Okay, that's a shortcut for adding in an R chunk. Huh? What was it? Control Alt I on a PC? Okay. to add in code chunks, and this is what we call a pipe. It's based on like the bar pipe of bash. So this feeds in information kind of in the opposite way, which was talked about last week. You can also type it in itself as like the %, but that gets kind of tiring. Okay, so diplar is really useful when we are subsetting data. So it works in different classes as well. So if you wanted to convert the data frame of Swiss into a table or tibble. Dipler. It comes out as a table, and it's a little bit more intuitive when you're looking at the object and how it displays it. This one? Yeah. So you can, if you have your cursor inline, you can just do Command Enter.
Couldn't find function.
Oh, so that probably means it was the same thing as me. You didn't install the library yet, so try loading in the library.
So what's the command for?
It's right here. It's highlighted on the screen, library dipler. Library dipler. So we'll have your green stickies up if you have the library installed and this table function. Good. Okay. So this function is actually the same as if we type Swiss pipe table for data frame. And then also because it knows that it's a function, it actually doesn't even need the brackets at the end. Swiss table data frame. So these will actually all have the same output. So base R will write their functions more like this. You can rewrite it into here saying that I want to pipe this object Swiss into this table function. Or you don't need the brackets at the end. And if you put this period, this tells it to look at the object that was before the pipe to put into the function afterwards. So we're just going to avoid writing Swiss, and we're gonna make a new data set. Swiss. If you wanted to run if you wanted to run all of this together, you can highlight it and press Command Enter, or you can shortcut on a Mac, which is Command Swiss Shift Enter. I typoed. All good? Okay. So I'm just going to add another chunk here. So another really useful property of diplar is the select function. So if we type select, dataset 2, education, Catholic, fertility, then here it will subset out just the column, just these 3 columns out of the data set 2 object that we put inside of it. And similarly, we can also write this using the pipe function, pipe layout. Which is actually also the same as so these will all run the same thing. They're just different ways of writing it. And then another thing that we commonly have to do is rename these columns. So another function in this library is dataset to rename. So the format of this function is this is the name that it is currently existing at, and this is the name that we want to put in. Sometimes periods don't run well in titles, so rename. So if I wanted to use a rename function to rename old name into new name, this is how I would write it. And this, so I'll run this line. And this will actually pull out all of the columns that are in the data set with the renamed column here. But if I wanted to do that and just pull that one column out, I can use the select function. So the select function is a little bit different from rename because now I just have a data frame with a one column that is renamed to the title that I want it to be. Okay, and the next next function we're gonna go over is filter. So filter, this is really useful when you're trying to subset some data sets, if you're trying to only look at something with a blood pressure less than 20 or 20. Another syntax thing of R is, you notice a lot of the times here, the equal sign is used to donate an attribute to a parameter. So, but if you actually want something to numerically equal it, you need these double equal signs. So in this one, we're filtering out the data set for anything under the Catholic column that is less than 20, and I need an examination value of exactly 15. So that will subset our data set out for us. So if we wanted to write this out with a pipe function, it'd be similar. Whoa. So these ones would all give out the same effect of filtering it for the two parameters. Okay.
So it says here if you want to filter out two different conditions, can I put or? Like one condition for another?
I'm not sure how to do that with the pipe, the vertical. Yeah. So if we wanted to do that, you would put here, there's a bar in a Mac. It's right under the delete button. This one, right? Yeah, so we get more of that. So then you can string along parameters with this. Is it pipe? But it's just a vertical bar. Yeah.
Can you comment out like a line? I say when to run only one of those to see how it compares.
Yeah, for sure. So if you wanted to, for example, just filter out for the Catholic 21st, I would close the bracket of that and then put a number sign here. And see how it changes color in RStudio? This is now commented out. I also like to use a comment out on the end of this. So I'd say like, I don't know, filter one, what? One, if I'm gonna try different parameters. Where?
What's the difference between the single equal sign and the arrow pointing to define a variable?
Mm-hmm. So I think that it's like I think traditionally actually if you do x equals 5, oh, I think that's a bad idea because it already x equals 6. You can use equal sign, but I think that's an old way of programming that's not really in convention right now. So if you're assigning a function or an object or an actual object to a string, then you want to use the put arrow, whereas when you're specifying actual attributes within a function, so you would only use the equal sign within these open brackets. Yeah, you can use equal sign outside, but it's not good convention right now. Yeah. Okay. Okay.
The string line is or and.
Or. So what I have, let me take this guy out here. So what I have here is I want to filter data set 2 on either Catholic or this examination filter. If you want and, you just string it along with a comma. So the comma means it has to fulfill all of these parameters before it will be brought into the new object. So similarly, if we wanted to combine different commands, we can also do that with multiple pipes. So if we put data set 2, oops, pipe filter 20 pipe select education fertility. If we run, so I'm gonna Command Shift Enter to run the whole chunk. So then it will first filter on this Catholic parameter and then select out the columns of education and fertility to display. So you can chain multiple ones of these. And this really is the advantage of using pipe, because if you write it out in normal R convention, it's a lot of brackets within brackets within brackets. And RStudio kind of helps you figure that out. For when you do multiple brackets, you can kind of move along and it'll highlight which bracket it corresponds to, but it can get confusing sometimes. So having these multiple layers of pipes will help you organize your code as well. Along with that, we can do dataset 2. Pipe filter. Execution. I'm sorry, I'm so bad with multitasking. Yes. Oh, shoot. I think that should. Yeah, so here we can actually build in if-else functions as well. So we're filtering on Catholic, and if we wanted to double check what these different parameters mean, you can do arrange. You can see this arrange function will arrange the rows by the variable. So we specified the variable as education, and then mutate from dipler, we'll add new variables. And this is, I think, preparing actually for the next step. Yeah, so it'll add new columns of whether it's infertile and this test column. Oh, let me just, if anybody's catching up with writing that code. Mutate added this if else. So if fertility is greater than or less than 50, then it adds into this column, it is infertile. So it adds a new column based on the characteristics of a previous column, right? Yeah.
Is the pipe the same function as plus?
It's actually the equivalency of a comma if you're going to string it out. Yeah. So you would have like filter dataset 2, comma, oh, is it? And then arrange. How would you write this out without the pipe? Oh, you would have to do like multiple, and then you would do like arrange like this. Yeah. So by you would take out these different and then mutate this. So you would have a lot of layers. So then after you write in your filter, here we'll do filter Catholic. Okay. So that would take care of our first line. So you see how it's highlighting. See how it's highlighting that open bracket with my closed bracket that I just closed. And then arrange, you want it to be on education. So let's just do those two. So you're saying now what you're inputting into arrange is this object. Does that make sense? So within filter, the object you're putting in is dataset 2. You're filtering on these parameters. And then when you're feeding it into arrange, you're actually feeding in the resulting object into arrange and then arranging it with education.
It's the same function.
Yeah, so this is the same as this. I was just too lazy to type out the end. These two will run the same. Here, I can show you. So take out this. So if I run this, I will get the same output as this. So base R writing functions, you will be very long, and this kind of, and using the pipe will move it more vertical.
another kind of thing, like for a second, you can think of it as since each of these functions takes in a data frame and puts out a data frame, that's why it's called a pipe. You're piping it through a series of operations. So writing it out with the pipe also makes those series of operations easier.
Mm-hmm. So when you're putting it into a range, you put in this whole object.
It's a data frame all the way through, just moving through a series of steps.
But that is only within the dplyr functions, right? Yeah. So if you're working with other like bioconductor packages, for example, they will be taking in data frames and objects, and you'll have to write them out the horizontal way, I guess. But you can always manipulate your data set within these dplyr functions and then export as a data frame and then move on with your other functions. Okay. So just going to insert another chain here. So if we just compare these two, set 2, mortality, set 2, pipe. Mortality. Sure. So actually, if we run this whole thing, so if you okay, so you might have to do this as well. So we're gonna work with tidyr as well. So just make sure you have that library installed in. So now I'll run. So the other cool thing about RStudio is that when you have two data frames that are outputted from the same R chunk, you can see them displayed down here. So there's two data frames. This one belongs to the function that's created here, and this one belongs to the function created here. So it's pretty useful when you're trying to compare two different things. So tidyr is really useful when you're trying to rearrange a data frame because we have kind of like horizontal and vertical output. So if you wanted to say, if you had a column that was like fertile, infertile, and if you wanted to just, how do I put it? As if you want to take out a column and just kind of arrange it vertically. Here, I'll show you. So, this one. Gather. Okay, so it has, rather than having each of the columns up here, it has kind of, the gather function will gather these columns and put it into a vertical format. As you can see by the dimensions here, this one's 47 by 5 and this one's 200 some by 2. So the measure is showing what it is measuring and the value here. So rather having all the outputs for fertility and agriculture vertically, we're seeing now all the fertility outputs and the values, and then it's stacking like the agricultural values vertically. I'm sorry, this is a really bad explanation for it. But so this data table will be very skinny, and it's just going to be a string and all the values coming out of it. And sometimes this is necessary when you need to graph it, and the graphing functions need a specific orientation of your input. Yes. So I think the last thing that we'll go over here before we end up is just knitr. RStudio, having it in the Markdown file is really useful for collaboration because you can actually output an HTML or a PDF document at the end of the day. So this is pretty useful rather than just sending a collaborator a code or a collaborator just a table output. You can then see what is going into it, so you can kind of walk them through. This is a data set that we started with, and then we're selecting for this, and then gathering for these two, gathering into these two columns. So it helps them interpret your code a little bit better as well. So when we're doing an output, library. You may need to install our Markdown as well. I'm not sure if it's already within RStudio when you download it now. You really need to render. Actually, you need to save the file first. Save file as R. So you have to save the file so you can have your Markdown file name, and then render intro. Sorry?
No package.
Oh, so then you'll have to do install.packages quotations are Markdown. That should solve your problem. So install this R Markdown package and then call it up in the library, and then we'll render the file. So depending on what you decided when you started your Markdown file, this one we decided we wanted an HTML document. You can also change to a PDF as well using that. Oops. Oh, I didn't run that. So then when you go to where your folder is specified, you'll have a Markdown file there that is created based on the code that we have just written. And it should have all your output still in line with it. Yeah. Just try that again. Update. What? Is anybody else having trouble? I just did this yesterday. Are you guys able to render your files? No? Has anyone been able to render their files? No? Okay, you might have to installing a library at the end of code sometimes, if it's actually using one of the packages that it's dependent on, then it will mess up the installation of further packages. So I don't really want to start this one over, but you can try it. It should work. I did it yesterday. The code should work. When you restart, just start off by installing this R Markdown file, and then it should work properly. Okay. Are there any other questions?
We actually have a lesson on our Markdown and using it more for reproducible document making in our which is documents. So we can keep an eye on that, and we'll learn more about our Markdown, how to use these to make your PDFs for your committee meetings and things like that, or reports. So just keep an eye on. Other questions? So anything anyone wants to see? Yeah. Future.
Yes.
So you talk about these.
The gather, yeah.
Is there any reverse, like instead of stacking it, I have a data set that's separating?
Yeah, so if you have a data set that's already kind of in this format, I believe it's spread. Yeah, spread is the reverse function where you can move something from a vertical output and then put it back into. So spread there.
Spread takes are just a column names. In this case, measuring value.
Yeah.
And it'll just bring it back to that point. And that also belongs to the type of package.
Does anyone have last questions or last requests for things to go over? Yeah.
Oh, yeah. So what's the, I didn't really quite catch the idea behind the power on that. It's just like it looked like sort of in a PDF format versus the comments in your code.
Yeah, exactly. So if you actually see here, those gray chunks, maybe that's
You can go on. I'll just map it.
So the gray chunks are going to be code, and you can actually make settings within the R for those graphics and say like don't show this when you
Include equals.
So, yeah. The output of that is you get like figures in your code with your paragraphs explaining the code of the figure, and then you don't actually show the code, but every time writing it, you're not showing it.
Okay.
So we'll actually go over like how to do that in that lesson, how to make your reports using litter and R.
Yeah.
But yeah, it's very it can be very useful. Like people out and the group actually use it to submit papers.
Whoa.
So that every time you format it, you don't need to change how you format. You
Yeah.
set that at the top, and then you don't have to worry about formatting.
Mhm.
It can be very useful.
And in scripts, a lot of the times I would start off my code chunk with like import data set from blah, blah, blah. But here you don't have to comment out so much. All the space in between each of the code chunks is automatically commented out and in the Markdown format. So you could just say like, I'm starting this. Oh, that is more for formatting, not for actually commenting out, but you can put just like import data set and then be like, you know, from GSE. Yeah. So this is all space for you to comment out and annotate your work a little bit clearer rather than having all this comment.
On the flip side, if you just think of it as
Mhm.
right, do an analysis from start to finish, keep your thoughts in one place.
Yeah, much closer to the Jupyter notebook.
So next week we actually have a continuation of a sort of